Today we are going to see about how to design a continuous beam and the design part by using IS456 in our STAAD Pro software, and we will apply different types of loads and we will take the different types of supports for the beam and we will see the displacement and how the beam will react due to its self weight. So first we have to open our STAAD Pro software. So we will open our STAAD Pro. So go to new project, click on space, give the name as continuous beam. So the length units will be in meters and the force will be in kilonewtons. So click on next. So click on add beam. Click on finish. So after that we will place this to our front view. Now go to geometry and click on run structure wizard, or else you can draw through grid also. So go to frame models. Here we have continuous beam. So here we can select how much length of span. So if you see, you can take us 12 meters, and we can change the length for this also. So we have to maintain this 12. So here we have, if we add, the total length should be coming up here. So it won't be able. So how much? 3, 3, 6, 9, 10, 11, 12. So here we have to cancel this and we can arrange, we can take meters of how much we will take 15. So it's divided, so okay, or else we will take a 10 meter span is enough for us. So click on apply. So go to transfer model, click on S, click on OK. So our beam has been created. So delete the snap node beam grid. So here we can see our continuous beam. So now for that, now we will go to general and we will give some supports. So go to create. So we will take fix and create. We will take the pin, create, and here we have the inclined tension or compression, enforced multi-linear spring, fixed, but we will select only this and MECH and effects. Click on add. So I'm taking 3 types of supports. So I'm giving the fixed supports. The first part, so click on geometry, you can see the node points. Go to general, support. So after that, I'm going to select this part to the last one and this. So we have to assign this. So click this, select the node, click on assign and S. So it has assigned. So again, now select this support, drag in between these points. So select the node cursor on assign and S. So it has assigned. So we'll assign the support at the end, assign and S. So we'll take this one under the middle. So click on assign and S. So we have assigned different types of supports. So now we will use the property of the beam. So we can take individual sections also. So I am taking a single section of 0.35 by 0.35. Click on add and close. So now select our beam. Select this property, assign to selected beams, assign and S. So in 3D we can see our cross section of the beams. So this is the size which we have given to our beam. So now we will define the material and take the concrete, assign the selected beam, assign. So the material has been assigned. So now we will go to loads and definitions. So we will only define the dead loads for this. Click on dead load and add and close. So for this, firstly we will add the self weight. So here we will take self weight, add and close. So we will assign this, assign to view, assign and else. So the self weight has assigned. So again go to dead load, click on add. So we will take the member load. So we have different types of loads here. So I'm taking the uniform forms of. So here we have to calculate our beam size. So for that, go to calculator. So I'm taking 0.35 into 0.35 into 25. So it is unit weight of almost 3.06, 3.0625. So it is acting downwards. So we will take minus. Along zy direction, click on add. And again I am taking concentration force of minus 4 kilonewton, click on add. So we can take linearly varying load along y direction. So I am taking here minus 2 to minus 5. So click on add and close. So now we will assign this unit weight for all the beams. So click on assign to selected beam, assign and it's. So it has assigned. So now I will assign the concentrated load. So I'm going to use cursor to assign, click on assign. So I'm going to assign here a concentrated load. And I'm going to assign this linearly varying load. So select this, assign. So we're going to assign here. So then we will add that number weight minus 3.0625. Add and close. So I will assign to this beam and this beam. Assign to selected beams, assign. So it is uniform load to all the beams, so that's why you can select assign to view, assign and assign. So in 3D we can see this. So the different types of load has been assigned. So now we will assign the load combination for defining load combination. We will take this factor as 1.5, select this one and add and close. This is the load combinations for this beam, continuous beam. So now we will analyze this structure. So we will add this and close. Run analysis. So we are done with 0 error, 0 warning and 0 nodes. So go to post processing mode, click on OK. So here we can see our beams. Click on beam. And this is the moment about Z and this is the FX and this is the FY. So here we can see about the FY and this is the Z and this is the moment. So these are the MZ. So these are the beam stresses acting on this our beams. So we will see the animation, click on deflection. Okay. So no beams are deflecting. Again go to animation, go to sectional displacement. Okay. So there is no sectional displacement. Now we will go to So we don't have any plate, so that means stresses. So we have the force limit, structure, scales and labels. So we can have the reports. So we can have all the node displacement values. So after that, we will design this beam. So for that, again go to modeling. So you can see this in 3D rendering view, our beam, and now we will go to general and go to design. Take concrete. So here we are going to design as per IS456 and select parameters. So here I am selecting compressive strength, yield strength and shear reinforcement, and the maximum reinforcement and the maximum size of secondary reinforcement. So here you can select whichever we want, or which factor, the spacing between the reinforcement or the torsion, everything we can check here. So the clear distance, the bracings, done. Okay, so go to define. So here I am going to take 120 grade, cont add. So the FY main is 405 close, and FY sectional is also my 405 close. So the main bars is of 20 dia I'm using, and the sectional bars is of 16 dia. And so the spacing between the main bar reinforcement is like the 2 units was 0.25. Click on add and close. Now go to commands, click on add beam, add, and take off, add and close. Now we have to assign all this property to our beam. So select on this FC and click on assign to view, assign and S. So next FY main, assign to view, assign and S. So FY sectional, assign to view, assign and S. So these also we have to assign all these properties to our section. So main, assign to view, assign and S. Design beam, assign to view, assign and S. So after assigning all this, again we have to go to analysis and print, click on add and close. Then after we add and close, now go to analysis, run analysis, save. So here again we are done with 0 errors and 0. Now we'll go to post processing mode, click on OK. So now we click on beam. So these are the Fx, Fy and all the stresses. And now we will go to the forces acting on a beam, the stresses. We select one beam. So here we get the stresses acting on that beam. So again we will go to animation, go to deflection. So no, nothing are deflecting. So here you can see the dead load. You can go to beam, select any beam, double click on it. So here we have all the properties. So there is geometric property. Here the loading condition. So this is the shear force bending. So this is the shear bending of this beam, and this is the deflection. So no deflection. So this is the concrete design. So here we got 5-10 @ 320. So 5 number of bars at the rate 10 mm dia at the rate 320 mm spacing to 16. So here also. So again here also, here you can see the number of bars, the stirrups, so everything we can see here. So here we can see, so this is how, and we can get the output. You click on the STAAD output, click on concrete design. So here we get the all the shear reinforcement. So here you can see the top reinforcement and the bottom reinforcement. So how much reinforcement is required. So beam number 2. So this is for the beam number 3 and 4. So this is all we can get here. So total in weight we need 634 kilonewtons. So 8 bars we need 202 and 10 bars we need 432. So this is how we can get all the shear reinforcement details also. So we can print it out by clicking this print, click on OK. and give a file name to save that and save it. So it will be saved. So this is how we can design a continuous beam with using different loading condition and supports in STAAD Pro software. Thank you.